Hello Senior 5 MCB. Today we are going to continue with mutation. I hope last time we had mutation, we discussed mutation lesson 1. So today now we are moving to second part of mutation. So now last time we finished on different forms of chromosome mutations. So now we are still having more forms of chromosome mutation, and now here I'm going to take you through all these remaining forms of chromosome mutation. Now there's what we call aneuploid. Aneuploid simply means changes in the number arise when an error occurs during meiosis. So you have heard that now it involves loss or gain of chromosomes. There's also non-disjunction. Non-disjunction here basically is a situation where a pair of homologous chromosomes fail to separate during anaphase 1 of meiosis. So you have had during formation of zygote, there's a tendency where a cell may have extra number of chromosomes or may have some chromosomes missing. So that is what we call non-disjunction. There's what we call proploid. A proploid basically involves the gain of the whole set of chromosomes, and this kind of chromosomal mutation, it is more common in plants than animals and illustrated with hybrid vigor. There's what we call autoproploid. Occurs when the chromosomal number of normal individual organisms becomes multiplying. This can occur when cytoplasm fails to separate during cytoplasmic cleavage. So basically, we are done with different forms of chromosomal mutation. So far, once you follow this illustration, here we have XX female. Then now here we have 2 eggs. There's an egg with 2 copies of X and another egg with 0 with an empty X chromosome. So now after fertilization, guess what is happening here? Then we have a female with a triple X. There's XO, there's X, XY, there is OY. So which means this kind of illustration simply explains to you how non-disjunction occurs. Now we are done with different forms of chromosomal mutation. Now we are moving to different forms of gene mutation. There is deletion, you have had last time. There is frame shift mutation. And under frame shift mutation, you have different forms. Again, there is insertion, deletion, duplication, frame shift mutation. We have inversion. There is also what we call insertion. So I hope last time we had a discussion about different forms of chromosome mutation. Today we are moving to different forms of gene mutation. So what you do here, you can just take your time, read and understand each form of gene mutation. You have to read deletion, frame shift mutation. There is inversion as well as insertion. Again, we have some sex chromosome abnormalities. Now, XO, Turner syndrome, a pair of sex chromosomes fail to separate during formation of an egg. So, when an abnormal egg unites with the normal sperm to form an embryo, that embryo may end up missing one of sex chromosomes, rather XX. So that is basically here. So when you check, this kind of abnormality also reflects the following characteristics, like lack of ovaries in female, no sexual maturity, and female sterile. So it is not good. There is now XXY, which is basically Klinefelter syndrome. It is also another kind of genetic disorder, which is most common in males. And again, here, basically this individual may have an extra X chromosome to a standard human male karyotype. So again, Klinefelter syndrome reflects characteristics. no secondary sexual characteristics in the male. Male, they tend to become also sterile. So Klinefelter syndrome is also dangerous, ideally. So there's also trisomy, which is also called the Downey syndrome. Each body cell has 3 copies of chromosome 21 instead of usual 2 copies. So still, as you can see, it has also some characteristics. Again, there is what we call Jacob's syndrome. I like this. This kind of abnormality, it is also most common in males. And again, here, the human male has extra male Y chromosome. So most boys born with extra Y have normal sex development and no problems with fertility when they mature. You have heard, like when you have extra Y chromosomes, you have more chances to produce baby boys. Oh, come on. So that's good. Oh, So 96% apparently normal males who have this syndrome may have higher than normal levels of testosterone. So you have heard they have this kind of hormone which is still common in males, testosterone. And again, boys, all males who have Jacob's syndrome, they tend to become relatively tall. I mean tall.